Welcome to the deep dive. Today we are wrestling with, well, a topic that's just completely exploded, hasn't it? Artificial intelligence.
It really has. It's moved way beyond the labs.
Absolutely. And it's now, a core engine of the global economy.
Yeah.
But we're trying to step back a bit from the headlines, the specific bots and things.
Right.
We want to focus on that core academic definition, AI as the science and engineering of artificial intelligent agents.
Exactly. And it's so ubiquitous now. I mean, you can hardly talk about any major industry without mentioning AI.
Sure.
The sources we looked at suggest it's not just another tech shift. They're framing it as like the driving force behind a whole new industrial revolution.
Wow.
And to really grasp that shift, you kind of need the underlying mental models, the foundations.
So that's our mission for this deep dive then. We want to explore those fundamental paradigms of AI, maybe trace its surprisingly deep philosophical history.
Yeah, it goes way back.
And also investigate this, well, increasingly complex ecosystem of human-AI cooperation. The goal is to give you quick but thorough knowledge, sort of the cheat code to understanding AI research without getting totally overwhelmed.
Sounds good.
Okay, so let's unpack this. Before we even get into algorithms and neural nets, we probably need to understand the, let's say, philosophical lineage of intelligent machines. Where does this idea even come from?
Yeah, it's crucial to realize this isn't just a 20th century thing. Not at all. The history stretches back, way back to antiquity.
The ancient Greek examples always get me. They weren't just like tech demos and stories. They were really digging into artificial life and its consequences.
Totally. You've got Talos.
The giant bronze automaton, right, around 700 BC.
Yep. And Hephaestus, the god of blacksmiths.
Ah, yeah, he was always making stuff.
He was often depicted creating automated golden servants, early conceptual robots, basically.
Huh.
But maybe even more profound is Pandora.
Pandora, how does she fit in?
Well, she was an artificial woman, created, not born. And her curiosity, famously, released all the evils into the world.
Oh, right. I never thought of her that way, as an artificial being. So even back then, these myths were exploring that ultimate ethical question.
Exactly. What happens when we create things that are so human-like, they kind of challenge our own sense of control?
Do those ancient warnings still feel relevant today, you think?
I think they absolutely do. They ground the whole discussion. They show this isn't a new anxiety. Then the philosophical quest shifted a bit in the classical period
Oh, so?
towards understanding human thought, but mechanically. You have Aristotle exploring the rational intellect.
Trying to figure out the organizing principles of our own intelligence.
Yeah, that was really the first stab at it. And that journey, well, it continued right through the Enlightenment.
Thinkers like René Descartes.
Grappling with mind-body dualism.
Which is basically trying to connect the physical machine, the body, with non-physical thought. Still a huge problem for AI.
Absolutely. And then you had Gottfried Leibniz, who was thinking about a universal language of thought.
Like a way to represent human reasoning logically,
Yeah.
computationally.
Pretty much. Laying that groundwork, conceptually at least.
But okay, for AI to become a science, you needed more than philosophy. You needed a working model for computation itself.
And that really arrived with Alan Turing in the 1930s.
This is foundational work.
Yes, specifically that 1936 paper on computable numbers. That gave us the theoretical Turing machine.
Which showed that any problem you could describe with simple instructions.
Could be handled by a general-purpose computer. It's like the conceptual blueprint for every computer, every AI system we have today. It's fundamental.
And then the Turing test, 1950. That set the first real benchmark for defining machine intelligence, didn't it?
It did. The idea was if a machine could chat with a human judge,
And the judge couldn't tell if it was human or machine.
then it passed. It defined intelligence purely based on performance, on behavior, not some internal feeling or consciousness.
But that focus on performance is where the philosophy kicks back in, right?
Exactly. John Searle's famous Chinese room argument. It's a direct counter to the Turing test.
Explain that one again briefly.
Searle basically says, imagine someone in a room who doesn't know Chinese, but they have a massive rule book. They get Chinese symbols passed in, follow the rules, and pass out correct Chinese symbols.
So to someone outside, it looks like they understand Chinese.
Right, they pass the test. But Searle argues the person inside the room still has zero genuine understanding. They're just manipulating symbols.
So just acting intelligent isn't the same as being intelligent or conscious.
That's the core critique. It's a crucial distinction. But regardless of that debate, the field itself really caught fire in 1956.
Dartmouth.
The Dartmouth Summer Research Project on Artificial Intelligence. That's where the term artificial intelligence was actually coined.
And it sparked this huge wave of optimism.
Intense optimism. Maybe a bit premature in hindsight about how fast things would develop.
Okay, which brings us more towards today. We've got decades of work now. But if intelligence itself is so tricky to define, how did researchers even organize the field? How did they approach building it?
Yeah, that's where it gets really interesting. They had to categorize their goals, basically. Russell and Norvig's textbook offers a classic framework.
The 4 goals.
Right. Based on 2 dimensions. First, are you aiming for human-level performance? Or are you aiming for ideal rationality?
Okay. Human versus rational.
And second, are you focused on the process of thinking or just the outcome, the acting?
Got it. Thinking versus acting. So that gives you 4 quadrants.
Exactly. Thinking humanly, trying to replicate how humans actually cognize. Thinking rationally, using formal logic, symbolic reasoning.
Acting humanly, that's like passing the Turing test, mimicking behavior.
Yep. And acting rationally, this is about maximizing goal achievement, making the best decisions to reach an objective.
Okay, of those 4, which would describe, say, 99% of the AI we actually use every day,
Right.
mapping apps, recommendation engines, that kind of stuff.
Almost entirely the 4th one, acting rationally.
Really?
Yeah. These systems are designed to maximize some expected utility or achieve specific goals super effectively. Whether they think like humans is usually irrelevant for the task.
Ah, that makes sense. And that connects pretty neatly to the idea of strong versus weak AI, doesn't it?
It does, perfectly. Weak AI or narrow AI. That's what we mostly have.
Specialized systems.
Right. Designed for very specific tasks. Siri answering a question, software recognizing a face in a photo, detecting fraud. They don't have general smarts or consciousness.
And strong AI. Artificial General Intelligence, AGI.
That's still the theoretical dream, mostly. A machine with human-level general intelligence, consciousness, the ability to learn anything, and transfer knowledge across totally different domains.
Okay, but here's a question. These large language models, LLMs, they can chat pretty convincingly, they can write code, they plan stuff across different areas. Is that line between weak and strong starting to get a bit fuzzy?
That is the key debate right now, isn't it?
Or is it just incredibly clever symbol manipulation like the Chinese room,
Yeah.
just massively scaled up?
The performance is certainly blurring the lines, making us ask those questions. But if we look at how they're built, the actual methodologies, the tribes of AI, as some call them,
Yeah, let's break those down. The core paradigms.
you see a constant push towards maximizing that rational action, achieving the goal.
Okay, first tribe, symbolic AI, the classical rule-based approach.
Think of this as the rule book tribe, going back to that Chinese room idea in a way. It's rooted in logic. Knowledge is represented explicitly with symbols and rules like E if temperature is high and D pressure is low, then activate cooling system.
So early expert systems use this, like medical diagnosis.
Exactly. Systems fed with rules provided by human experts.
Okay, second tribe, connectionist AI.
This is the brain-inspired tribe. Artificial neural networks.
The ones you hear about all the time now.
Right, using interconnected nodes, artificial neurons, to process information in a way that's loosely modeled on biological brains. They learn patterns from data.
And the third?
Statistical AI, or more commonly now, machine learning.
The dominant approach today.
Absolutely. This is the data-driven tribe. It uses statistical techniques to let the system learn patterns, make predictions, and find rules directly from data rather than being explicitly programmed with them.
Now, what's crucial for you listening is to understand these tribes aren't like totally separate camps anymore, right?
Not at all. Statistical AI, machine learning, it's the huge engine-driving convergence.
How so?
Well, ML techniques are used to train those neural networks in connectionism. And ML can even be used to discover or learn the explicit rules for a symbolic system automatically from data.
So statistics are kind of powering progress across the board.
Exactly. It's the mechanism. And you also see hybrid systems emerging. Bayesian networks are a good example.
What do they do?
They sort of bridge the gap. They use symbolic representations, nodes for variables, arrows for relationships, but combine that with probability theory from statistics.
Ah, so they can handle reasoning when things are uncertain.
Yeah.
Like diagnosis with incomplete info.
Precisely. They leverage the structure of rules, but add the power of statistical inference.
Okay, so we've got these different ways of building intelligence, different goals, different methods. But is there one single concept that kind of ties them all together, a way to think about how these systems operate in the world.
Yes, there is. And it's the concept of the intelligent agent.
The agent framework.
It's the great unifier, really. An
Hmm.
intelligent agent is just, well, any computational entity that's designed to interact with some environment.
Yeah.
It perceives information using sensors, it processes that information, and then it takes actions using actuators.
Actuators being like robotic arms or wheels or even just generating text.
Exactly. Actions to achieve specific goals, and importantly, doing so autonomously.
Ah, autonomy. That seems key. Acting without constant human hand-holding.
That's the core idea. And these autonomous agents, there's some consensus on their defining features.
Like what?
Well, autonomy, obviously. Reactivity, responding to changes in the environment in real time.
Makes sense.
Proactiveness, taking initiative to achieve goals, not just waiting for something to happen.
So goal-oriented.
Definitely goal-oriented, often capable of communication, learning and adapting over time, and sometimes even social ability, coordinating with other agents.
And their behavior is always aimed at.
What? Maximizing their goal achievement based on the knowledge they have.
Gotcha. And to actually design these agents, researchers use a specific framework to describe the task, right? PEAS.
Yep, PEAS. It's a systematic way to characterize the task environment.
Cheese for.
Performance, the measure of success. How do you know if the agent did a good job?
Yeah.
Environment, the external context it operates in. Is it physical,
Yeah.
virtual, static, dynamic?
Yeah.
Actuators, how the agent actually does things. Like we said, motors, screens, text output.
And bets.
Sensors, how it perceives the world. Cameras, microphones, LiDAR, keyboard input, data feeds.
Okay, PS. Performance, environment, actuators, sensors, useful checklist.
And we can also categorize agents based on how they make decisions, right? Their internal architecture.
We can. You have simple reactive agents.
Like a Roomba bumping into a wall. Pretty much. They work on simple percept-to-action rules. See obstacle, turn left. No real internal model or planning. Great for quick, real-time responses.
Then the more complex ones.
Deliberative agents, these guys think. They maintain an internal model of the world, they plan sequences of actions, they consider the future. Slower, but more sophisticated.
And hybrids.
Combine both. Quick reflexes for immediate threats, but also longer-term planning when time permits. Many real-world systems lean towards hybrid.
Now, there's one architecture mentioned in the sources that seems particularly interesting because it tries to model human-like reasoning states. The BDI architecture.
Ah, yes. Beliefs, desires, intentions. It's a cognitive architecture aiming to model practical reasoning in a way that feels intuitive to us.
Let's use an example maybe. An autonomous vehicle trying to change lanes. How would BDI apply?
Okay, perfect. So beliefs are the agent's informational state, what it knows or believes about the world right now.
So for the car, that's sensor data. Like there's a truck in the next lane, the truck is braking, the speed limit here is 70 miles per hour.
Exactly. It might be incomplete or even slightly wrong, but it's the agent's current picture of reality based on its sensors.
Okay. Then desires.
Desires are the motivational state, the long-term objectives or preferences, what the agent fundamentally wants to achieve.
For the car. Reach the destination safely, maximize fuel efficiency, obey traffic laws, things like that.
Precisely. These are the ultimate goals driving its behavior.
And finally, intentions.
Intentions are the deliberative state. This is what the agent has actually chosen or committed to do in the near future based on its current beliefs and desires. It's a specific plan it's adopted.
So, based on its belief that the lane is clear and its desire for safety and efficiency.
Its intention becomes initiate a lane change maneuver within the next 3 seconds. It's the chosen course of action right now.
That BDI model seems useful because it makes the agent's reasoning more transparent, more interpretable. You can ask why it formed a certain intention.
Absolutely. And that transparency is becoming absolutely essential because we're really past the point of just viewing AI as this separate thing over there.
We're in a human-AI ecosystem now. It's about cooperation.
We've definitely moved into symbiosis. It has to be cooperative. AI is incredible at crunching massive data sets, finding patterns, raw computation.
But humans bring common sense, creativity,
Yeah.
ethical judgment, understanding context, stuff that's still really hard for AI.
Exactly. We need both working together.
And this cooperation happens along a spectrum of control, right? These loop concepts, human in the loop, hit L.
Right. HIT-L means continuous human involvement. The human is constantly providing input, guidance, validation.
Like labeling training data for an image recognizer, or reviewing every decision an AI suggests.
Yeah. or providing corrective feedback, the human is deeply embedded in the process to ensure reliability and alignment with what we want.
Okay. Then there's the other side, machine in the loop, or sometimes called human in command.
This is where the AI is more of an assistant augmenting human intelligence. It does the heavy lifting data analysis, providing recommendations, highlighting options.
But the human makes the final call.
Zero.
The human retains ultimate control.
Correct. The AI empowers the human, but doesn't replace their judgment.
And this augmented relationship, it's supported by specific machine learning techniques that explicitly rely on human expertise, isn't it?
Very much so. Take active learning, for instance.
How does that work?
Active learning is pretty clever. Instead of asking humans to label massive amounts of random data, which is expensive, the machine strategically identifies the data points it's most uncertain about, the ones where it feels it would learn the most from clarification.
And then it asks a human.
It asks a human oracle to label just those specific, tricky instances. It's like the AI raising its hand and saying, "Teacher, I'm confused about this one," saves a ton of effort.
Smart. Okay, what about inverse reinforcement learning, IRL?
IRL is more subtle. In standard reinforcement learning, you give the agent a reward function, get points for doing X. In IRL...
Don't tell it the reward.
Right. Instead, the agent observes an expert performing a task like a human driving a car well. And it tries to work backward to figure out what hidden reward function, what intentions or goals must have been driving the expert's actions.
So it's learning the why behind the actions, not just copying the actions themselves.
Exactly. It learns the underlying values or preferences. Very powerful.
And the technique that's really shaped our experience with things like ChatGPT, reinforcement learning from human feedback, RLHF.
Yes. RLHF has been huge for making large language models more helpful, harmless, and honest, as they say.
How does the human feedback work there?
Typically, humans are shown two different outputs from the AI in response to a prompt.
And they just pick which one is better.
Yeah, they provide comparison-based feedback. This response is more helpful, safer, more accurate than that one. Or they might rank several outputs.
And the AI learns from these preferences.
Exactly. This feedback is used to train a separate reward model that learns to predict human preferences. Then, the main AI model is fine-tuned using reinforcement learning to maximize the score from this reward model. Essentially, it learns to generate outputs that humans are likely to rate highly.
Which is why they generally try to be helpful and avoid problematic content. It's learned alignment from human preferences.
Precisely, and that leads us straight into the ethical imperative here. All this cooperation, all these powerful systems, it all hinges on trust.
Trustworthy AI, that's the goal. Bodies like the European Commission's AI high-level expert group, they define it based on three components, right?
Legality, ethics, and robustness. It has to comply with laws, align with ethical principles, and be technically reliable and safe.
And for you, the user, what are the key requirements that actually build that trust?
Well, things like respect for human autonomy. The AI shouldn't undermine your agency or freedom to make your own choices. You need to stay in control.
And explainability, or XAI. That seems huge, especially with these complex black box algorithms like deep learning.
Absolutely vital. We need transparency.
Yeah.
Users, especially in high-stakes areas like medicine or finance, need to understand why an AI made a particular recommendation or decision. You can't just trust it blindly.
Makes sense. You need to be able to interrogate the reasoning.
And finally, human agency and oversight. This means, first, potential risks, especially to human rights, have to be assessed up front. And second...
You should always have a choice.
Yes, you should always have the option to interact with a human instead of an AI system, especially for important matters. And that requires clear labeling, knowing when you are dealing with an AI.
Okay. Wow, we've covered a massive amount of ground pretty quickly there. From ancient myths about automata...
Yeah, Talos and Pandora...
through the philosophical roots, Turing, the different paradigms like symbolic and connectionist.
The unifying idea of the intelligent agent, PEAS, BDI.
And landing on this crucial human-AI ecosystem, the loop concepts, learning from feedback, and the absolute necessity of trust and ethics.
It really feels like we're in an AI renaissance, doesn't it? Driven by this incredible explosion in data, the power of deep learning, and just sheer computational horsepower.
A Cambrian explosion of capabilities, as some sources put it.
Yeah. And as we try to harness all this, the source material throws out a really provocative, almost radical idea for the future.
Ooh, what's that?
Well, if these AI algorithms are becoming so powerful, so capable of building robust, complex systems, Why not leverage that same power to try and actually imbue moral and ethical principles into the AI itself
Yeah.
directly?
Whoa. Not just aligning it through feedback like RLHF, but actually building ethics into its core reasoning.
Kind of. Now, replicating the full richness and subtlety of human sociocultural ethical learning, that's an immense challenge, maybe impossible.
Understatement.
But the argument is that innovation in this area, finding ways to make AI systems inherently more sensitive to ethical considerations, is probably key. It's how we ensure the beneficial uses of AI ultimately outpace the potentially harmful ones.
So we need to be vigilant about the risks, obviously.
Absolutely vigilant. But also, we need to fearlessly embrace the incredible possibilities this new era is opening up. It's a balancing act.